Hello everyone. In this video I'm going to discuss about triangle chapter, that is class 10th. So firstly we will move on to the basic about triangle. So what is the triangle? Triangle is nothing but it is the closed figure, or it is a one of the polygon made up of three line segment, right? So and also here this triangle has three sides, three vertices and three angles. So here sign in ABC. So this is the one of the triangles and it contains three sides, that is sides are so AB, BC and AC, and angles are angle A, angle B and angle C. Then vertices. So vertices are vertex A, vertex B and vertex C. So these are the basic definitions of the triangle. So triangle is nothing but it is the closed figure, and also it is a one of the polygon made up of three straight lines. So it has three sides, three angles, three vertices. So next, formula for finding the area of triangle is, so we use the formula for finding area of triangle is generally we use this of into base into height. So next, perimeter of triangle. So perimeter of triangle is, so what do you mean by perimeter? Perimeter is nothing but sum of the length of all sides of the geometrical figure. So here a triangle contains three sides. So it means the perimeter of this triangle is AB sides, AB plus BC plus C. So generally we take perimeter of the triangle is sum of the sides of the triangles. So for finding the perimeter of triangles. So next we will come to the types of triangles. Types of triangles. So based on sides and based on angle we divide the triangles. So based on sides and based on angles. So firstly based on sides. So based on sides we divide the triangle into three parts. So three types, that is first one equilateral triangle. Second one isoscale triangle. Third one is scalene triangle. So let's move on to the equilateral triangle. What do you mean by equilateral triangle? Equilateral triangles. So here I am considering one of the triangles, that is A, B and C. So here it is 3 centimeter. It is also 3 centimeter, and this side also 3 centimeter I am taken. So here in this triangle ABC you may observe all sides are equals, right? So AB is equals to 3 centimeter and BC is equals to 3 centimeter and AC is equals to 3 centimeter. So if the triangles has all sides are equal, that triangle we called it as equilateral triangle. So it's nothing but all sides of triangles, are equal. We called it as equilateral triangles. So in equilateral triangles, all sides of the triangles are equal. So that is AB is equals to BC is equals to AC. So this is the one of the example for equilateral triangle. Next, isoscales triangles. Isoscales triangle. So here I am considered one of the triangles, that is so DEF. You may named as DEF here and named as DEF here. So DE is 4 centimeter and EF is 5 centimeter. DF is 4 centimeter. So here in this triangle DEF, we have to observe here DE is equals to DF, right? So two sides of the triangles here same, so that is 4 centimeter. So isosceles triangle is nothing but any two sides are equal in a triangle, so we called it as isosceles triangle. So any two sides, so here you take DE, so DE is equals to 4 centimeter and DF is equals to 4 centimeter. So these two sides are equal. So isosceles triangle is nothing but any two sides are equal in triangle. We called it as what? Isosceles triangle. So here in DEF, in triangle DEF, we write a DE is equals to DF, that is 4 centimeter, right? So this is the one of the example for what? Isosceles triangle. So next, scalene triangle. Third one is scalene triangle. In a scalene triangle, A, B, C. So in these triangles, here I am taking AB as 3 centimeter and BC as 4 centimeter and AC as 5 centimeter. You may observe here in this triangle ABC, so side AB is measured 3 centimeter and BC is measured 4 centimeter and AC is measured 5 centimeter, right? So in these triangles, all sides are different in measure. So scalene triangle is nothing but all sides are different in length or in measure. We called it as scalene triangle. So here in triangle ABC, so AB is equals to 3 centimeter, BC is equals to 4 centimeter and AC is equals to 5 centimeters, right? So all sides are in different measure. So we call that types of triangle as scalene triangles. Next, based on angle. So based on angle, how we divide the triangle? Let's see. So based on angle. So here also we divide the triangle into three types. So first one is acute angle triangle. So next one is right angle triangle. So third one is obtuse angle triangle. So first one is acute angle triangle. So in acute angle triangle, here I am considering triangle ABC. You may observe angle A is contains 60 degree, angle B is 60, angle C is 60. So it means all angles is less than 90 degree, right? So acute angle is nothing but all angles in a triangle are less than 90 degree. We called it as acute angle triangles. In a triangle ABC, we have angle A is equals to 60, angle B is equals to 60, angle C is equals to 60. You may take any angles less than 90 degree. So that we called it as acute angle triangle. Acute angle triangle is nothing but in a triangles all angles are less than 90 degree. We called it as acute angle triangle. For example, ABC, angle A is contains 60 degree, angle B is contains 60 degree, angle C is contains 60 degree. Next, right angle triangle. So here observe in a right angle triangle. So I am considering triangle XYZ. In this triangles, one of the angle is equals to 90 degree, right? So right angle triangle is nothing but in a triangle any one of the angle is equals to 90 degree, that we consider as a right angle triangle. So right angle triangle is nothing but any one of the angle is equal to 90 degree. That triangles is called what? Right angle triangle. So in the triangle XYZ, so here angle X is equals to 45 degree, angle Y is equals to 90 degree, angle Z is equals to 45 degree. So this is the one of the example for right angle triangle. So next is obtuse angle triangle. So obtuse angle triangle. See, you observe here, I am considering triangle PQR. In PQR, here angle Q is measure 120 degree, angle P is measure 30 and angle R is 30 degree. So obtuse angle is nothing but any one of the angles is more than 90 degree. We call that triangle as a obtuse angle triangle. So any one of the angle in triangle is more than 90 degree. We called it as obtuse angle triangles. For example, in PQR, in triangle PQR, angle P is equals to 30 degree, angle Q is equals to 120 degree, and angle R is equals to 30 degree. So this is the example for obtuse angle triangles. Next we will move on to the similar figures. So you may observe here two circles. So one is the radius is 2 centimeter, another one is 4 centimeter. We know these two are circle shapes, right? So, but here these two size are different, right? So first one circle, it has a radius of 2 centimeter, second one it has radius of 4 centimeter. So these two are similar figure. It means these two are same shape but different in a size, right? So here next in a triangle ABC, and DEF. So AB, see, in a triangle ABC, each side has 3 centimeter, right? So in a DEF, it has each side 5 centimeter. These two triangles are equilateral triangles but different in measure, correct? So next, here ABCD and DEFG are the two rectangular shapes. Here also ABCD is smaller than DEFG, but these two are same shape. So similar figures is nothing but the figures which has same shape but different in size. We called it as similar figures. So next we will move on to the congruence of the figures. So here observe these two circles. Here I am considering similar examples. So here these two circles are have same radius, right? So this is the first one circle. So yes, 2 centimeter as radius. Second one also 2 centimeter has a radius. These two circles are same size and same shape, right? So these two are same shape and size. Consider next examples, that is ABC and DEF. So here ABC triangle, each side has 3 centimeter, and DEF also it has 3 centimeters each side, right? So these two triangles are size is size also same and shapes also same. So these two triangles we called it as congruence. So here next pentagons, pentagons you may consider. So this pentagon, so here you may name it as A B C D E, and U V W X Y. So here A B BC and AC DE has 1 centimeter. Here also UV VW Y and YX as 1 centimeter. Here in a ABCDE, CD has 2 centimeter. In UVWXY, WX has 2 centimeter. It means pentagons are in the same size and same shapes, right? So next one is two rectangles. So here PQRS and ABCD. So these two are the two rectangle with the same measurement. So these types of figures we called it as congruence. Is nothing but if we considering the figures, the figures which have same shape and same size, we called it as what? Congruence of the figures. So figures which are have same shape and same size, we called that figure as congruence figures. So here one note you have. So note. So here if we considering these congruence figures, we can say these are all similar figures, right? So you may observe here. So these are all similar. It means same shapes. And also you may consider similar figures. These figures here, similar figures, it has same shape but in a size these are all different. For that we can say all congruence so are similar but all similar figures are not congruent. I think you got the points, right? So what this means, all congruence we can say similar figures, but all similar figures we can't say congruence. So next, similarity of triangles. So before going to this, just let's see the general definitions of similar similarity of the figures. Here, if we considering any polygons, if they are similar, they have to satisfy these two conditions, that is two polygons of same number of sides are similar. This is we know, right? If their corresponding angles are equal and their corresponding sides are in the same ratio. So if the two figures that are satisfies these two conditions, that figures are similar figures. So for proving of that or checking of that, let's take two quadrilaterals, right? So here ABCD and PQRS are the two quadrilaterals of AB is 1.5 centimeter, BC is 2.5 centimeter, CD is 2.4 centimeter, and ED is 2.1 centimeter. And angle A is 105 degree, angle B is 100 degree, angle C is 70, and angle D is 85 degree. Okay. In another quadrilateral PQRS, PQ is 3 centimeter, QR is 5 centimeter, RS is 4.8 centimeter, SP is 4.2 centimeter, and angles P is 105 and Q is 100, R is 70, S is 85. So let's check these two quadrilaterals is similar or what. So firstly, what the rule says, so here two polygons of the same number of sides. So here sides are same, right? 1 2 3 4. Here 1 2 3 4 sides, right? If their corresponding angles are equal, and another condition is their corresponding sides are in the same ratio. Firstly, we check the corresponding angle. So corresponding angles, right? So next, for the corresponding angles of A is angle P, right? So corresponding angle of A is equals to angle P. So here also corresponding angle, how much it has? 105 degree. Here P is consists 105 degree Celsius. So we can say angle A is corresponding to angle P, right? So these two sides are, these two angles are same, so that is 105 degree. So next, the corresponding angle of B is Q, right? So here corresponding angle of B is Q. So here angle B contain 100 degree and angle Q contains 100. So these two angles containing same measurement. So angle B is equals to angle Q. So BQ are the corresponding angles. So here angle C is corresponding to angle R. So here angle C is corresponding to angle R. Here observe, angle C contains 70 degree and angle R is contains 70 degrees. So both have same measure. So angle C is corresponding to R. Both are consist 70 degree. So next, angle D is corresponding to angle S, right? So these two are the corresponding angles. D and S are the corresponding angle and measure has 85 degree and 85 degree, correct? So here corresponding angles are same. So A is corresponding to P and these two angles have 105 degree measure, and BQ are the corresponding angles that also have same measure, that is 100 degree, and B is corresponding to R and if these two angles contain 70 degree, and D and S are the corresponding angles that also contain same, that is 85 degree. So next we have to check what corresponding sides. So corresponding sides. So here AB is corresponding to PQ, right? So here AB is corresponding to PQ. Here we have to check the ratios. That's why I am writing like this ratio form. So AB corresponding to PQ. So AB has 1.5 centimeter and the PQ it has 3.0 centimeter, right? So here it is in the form of decimal, so you have to multiply these two numbers with 10. So you have 50 divided by 30. So 15 ones are 15 twos. How much you get? 1 by 2. So ratios, how much you get? 1 is to 2. So next, the ratios of AB and PQ. AB over PQ is equals to 1 is to 2. Next, so BC is corresponding to QR, right? So BC is corresponding to QR. So we have to write it in a ratio form. So measure of BC is 2.5 and then QR is 5.0. Here also doing same calculations. It will become 25 and the denominator became 50. Right, so 25 divided by 50. So 25 ones are 25 twos. How much you get? 1 by 2. So the ratio is 1 is to 2. So next, here CD. So here CD is corresponding to RS, right? So you have to write it in a ratio form. CD divided by RS. CD over RS. So measure of CD is 2.4 and RS is 4.8. So similar 24, and it when we multiply the 10 both numerator and denominator, we have 24 and 48. So 24 ones are 24 twos are, so 1 by 2. So ratio is 1 is to 2. So next is AD is corresponding to PS. That means DA, AD you may take anything. So DA is corresponding to SP is equals to DA value is, measure of DA is 2.1 centimeter and SP is 4.2 centimeter. So when we multiplied these two numbers, means numerator and denominator, with the 10, we get 21 by 42. So 21 ones are 22, twos are 42, 1 by 2. So it is 1 over 1 is to 2. So here you may observe, so corresponding angles are equal here, right? So and also corresponding sides ratio. So AB by PQ ratio we get 1 by 2. So BC by QR, it means the corresponding sides of BC is QR, the two ratio we get 1 is to 2. And CD is corresponding to RS, the ratios of these two sides we get 1.2, and DA is corresponding to SP, and this ratio of these two sides we get 1 is to 2. So what to give the conclusion here? So this given quadrilaterals, what we consider these two quadrilaterals, that is ABCD and PQRS, are what? Similar figures. So given quadrilateral or similar, given quadrilateral or similar. So next we will check the similarity of the triangles. So for that, here we take two triangles. So triangle ABC and triangle PQ, so R. So let's check the similarity by using these two triangles. So here ABC and PQR are the two triangles. Here AB contains 4 cm, BC is 2 cm, CA is 3 cm, and then PQ is 8 cm, QR is 4 cm, RP is 6 cm. So next, check the corresponding angles. So let's see, the corresponding angles are equal. Corresponding angles are equal or what? So corresponding angle of A is P, right? So these two angles are lies in the same side. So corresponding angle of A is P, angle P. So here angle A is contain 20 degree and angle P is also containing 20 degree. So that's why we can write angle A is equals to angle P, that is 20 degree. So AP are the corresponding angles. So the two angles are lies on the same side of the triangle. So here angle B is corresponding to angle Q. So angle B measure is 70 degree, angle Q is 70 degree. So we can write angle B is equals to angle Q. So that is 70 degree. So next corresponding angle of C is angle R. So the CR are the lies on the same sides, right? So say the measure of C is 90 degree and measure of angle R is 90 degree. So we can write angle C is equals to angle R, that is 90 degree. Right. So here corresponding angles are equals. So corresponding angles are equal. Next we see corresponding sides ratio. So next corresponding ratios of sides. Ratios of sides. So here, so AB, the corresponding side of AB is PQ. So AB divided by PQ. So we have to write the corresponding sides in a ratios form. So AB by PQ. So AB is corresponding to PQ. So then measure of AB is 4 centimeter. Then measure of PQ is 8 centimeters. So 4 ones are 4 twos are. We get 1 over 2. So that means 1 is to 2 we get. So next BC is corresponding to QR, right? So BC is corresponding to QR. So value of measure of BC is 2 centimeter and QR is 4 centimeter. 2 ones are 2 twos are. So 1 over 2. So we get 1 is to 2. So next CA is corresponding to RP. So we can write AC or CA, we may write anything. So AC is corresponding to PR, correct? So AC is equals to 3 centimeter and PR is equals to 6 centimeters. 3 ones are 3 twos are 1 over 2. So here also we get same ratio, 1 is to 2. So what we have to say? So corresponding, therefore corresponding sides ratio are equal in a given two triangles, correct? So therefore in this figure, that is ABC and PQR triangle, ABC and triangle PQR are corresponding angles are equal and ratio of corresponding sides are same or equal. So therefore ABC, triangle ABC is similar to triangle PQR. So we may write it as triangle ABC similar. So this is the symbol we use, represents the similarity. So similar to triangle PQR. So symbol, this is the symbol we use to represent the similarity. Okay. So here in this chapter you may add one of the new letter, that is proportional. So proportional is nothing but corresponding sides ratio are equal. So So proportional is nothing but corresponding sides ratio are equal. We may call it as proportional. Next we will move on to the exercise questions, that is 2.1. So first questions, all the circles are dash corresponding and similars. So all circles, if we considering many circles are different in size, it means the radius are differ, right? So here all circles are similar, right? Next, all squares are dash similar or congruent. So all squares are have same shape but different in size. So that's we can consider all squares are similar figure. So next, all dash triangles are similar. So which types of triangles are similar, we may say? So that is equilateral triangles, because in equilateral triangles all sides are same. If we considering different equilateral triangles, shape will be same but size will be differ. So all equilateral triangles are similar. So next, two polygons of the same number of sides are similar. Again, two polygons of the same numbers of sides are similar if corresponding angles are dash and their corresponding sides are dash. Here in bracket equal and proportional. It means I am already told, if we considering any two polygons or any two figures, if they have to, if they similar, they have to satisfy the two conditions, right? So that is their corresponding angles are same or equal. So corresponding angles are same or equal, then their corresponding sides ratio are same. So the here they given proportional is nothing but what, corresponding sides are same, we can call that as proportional. So next one, give two different examples of pair of similar figures and non-similar figures. So here similar figures. So similar figures means the two figures are same shape. So here first one circles. So here these two circles are similar figures. Second one triangles. So these two triangles are similar triangles but different in size. So that's we called same shape but different in size. So that we call these two are similar figures or triangles. So here in the third example, so these two squares. So here these two squares are have same shape but different measures. So that we call it as two similar figures. So next, non-similar figures. So non-similar figures, here circle and triangles are different figures. So that's we can take these two are non-similar figures. So these two have different shape and different size. So here also square and pentagon. So square and pentagon are the different figures with the different shape and size. Here also rectangle and hexagon. So these two are the non-similar figures. So next question, state whether the following quadrilaterals are similar or not. So here they given two figures, that is PQRS and ABCD. So here PQRS measure is 1.5 centimeter, QR is 1.5 and RS is also 1.5, P is also 1.5. Here observe, so they are not given angles measures. So it is not equals to, we may say it is not equals to 90 degrees. So here in this, in the next figure ABCD. So this is one of the square because all sides have same length, and also here one line is perpendicular to another. So we can say that this given figure is square. So here AB is 3 centimeter, BC is 3 centimeter, CD is 3 and AD is 3 centimeter, and angles A is 90 degree. They only given angle B is 90, C is 90 and D is 90. So let's check the let's check the similarity. So firstly corresponding angle. So here corresponding angle of P is A. So angle P corresponding is A. Here angle P is, we don't know, but it is less than 90 degree, right? So by seeing only we can say this angle P is equals to less than 90 degree, but here angle A is contains exactly 90 degree. So we can say angle P is not equals to angle A, right? So next angle Q is also greater than 90 degree, but angle B is contains exactly 90 degree. So we can easily say Q is not equals to B. So next R and C. So R is corresponding to C, but observe the angles, measure of angle here. Angle R contains less than 90 degree, but angle C is has exactly 90 degree. It means angle R is corresponding to C, but angles are not equal. So next S is corresponding to D, right? Angle S is corresponding to angle D. So angle S, it is the measure of angle S, we may say is greater than 90 degree, but here D consists exactly 90 degrees. So we can say S is not equals to D. It means angle S is not equals to D. Corresponding angles are not equal. So therefore corresponding angles are not equal. And then also we can check the corresponding sides ratio. So next corresponding sides. So here PQ is corresponding to AB. Right, so measure of PQ is 1.5 and AB is 3 centimeter. So while we multiplying the 10 with both numerator and denominator, we get 15 divided by 30. So 15 ones are 2s are. So 1 over 2. So it means 1 is to 2. So side QR. So QR is corresponding to BC. So measure of QR is 1.5. BC is also 3. So here doing same procedure. So while multiplying 10 with both numerator and denominator, we get 15 divided by 30. It means 15 ones are 15, 2s are 1 over 2. So 1 is to 2. So next QS is corresponding to CD. So RS is corresponding to CD. So value of RS means measure of RS is 1.5 and CD is 3. So 15 over 30 is equals to 1 1 over 2. So 1 is to 2. Next side SP is corresponding to DA. So it's equals to 1.5 divided by 30. So 15 divided by 30 is equals to 1 over 2. 1 is to 2. Here you observe corresponding sides ratio we have same. Right, so but corresponding angles are not equal. So if we considering these two figures are similar, that satisfy the two conditions. What are that? Which are that? Corresponding angles are same and also corresponding sides ratios also same. Here corresponding angles are not equal. So therefore what we say? So given quadrilaterals are not similar. Given quadrilateral are not similar. So these are all about introductions of chapter triangles, that is class 10th, and exercise problem solutions, that is exercise 2.1. So thank you.